In this lesson, I'm going to run through two examples of factoring trinomials when a does not equal 1. Just as a quick refresher, the prefix tri means 3, right? So a trinomial is something with 3 terms. 1, 2, 3. Okay, this first one's going to be an example of where we also have a greatest common factor, which is really useful because we're going to basically run through everything. So I'm not only going to factor it, I'm then going to show you how to find the zeros of the trinomial as well. Okay, so the first thing for me to do is to go ahead and try to find a greatest common factor. So in order to do that, I need to look at each term. Remember, terms are separated by plus and minus signs, so I have 3 there. And kind of break them down. I like to break them down using prime factorization to make sure I don't make any mistakes. So that's what I'd recommend you guys do. So basically what I do is I start and I try dividing by 2 until I can't anymore. So I say 8 divided by 2 is what? Well, it's 4. Then I'm going to divide 4 by 2. 4 divided by 2 is 2. And now that I have all prime numbers, you can see I've broken that up as much as it can be. Now I'm going to take a look at 56, and I'm going to ignore that negative sign that's in front of it for now. All right, so again, same deal, where we start by trying to divide by 2, and then we divide by 2 until we can't anymore. Then our next prime after that is 3, so we divide by 3 until we can't anymore, and so on and so forth. So if I do 56 divided by 2, I end up with 28. Let's see if I can divide 28 by 2. Yep, I sure can. I get 14. What about 14 by 2? Yep, I get 7. And I'll let you know, 7 is another prime number, right? 1, 2, 3, 5, 7, 11, 13, so on and so forth. So I know that I've broken this up as much as I can. It's 2 times 2 times 2 times 7. And then I've got to break down 48. So I divide by 2 and get 24. I divide by 2 and get 12. Divide by 2 and get 6. Divide by 2 and get 3. Not too bad, right? These are actually pretty easy. 2 times 2 times 2 times 3. And as I can see, looking at the variables, I have an x times an x in that one, an x in that one, and no x's in the far right one. So I know that because there's no variable that appears in all 3, I'm not going to be able to take a variable out as a greatest common factor. What I'm going to do is rewrite these so that way I can see them more clearly. 8 is 2 times 2 times 2. 56 was 2 times 2 times 2 times 7. And 48 was 2 times 2 times 2 times 2 times 3. So written this way, it's a little easier for me to be able to see what's common between these. Okay, I have 3 2's that are in each of those. Note it's 3 2's, not 3, 6, 9, right? Because there's just 3 in each of them. So that means I can take 3 2's out. When I multiply those together, 2 times 2 is 4, times 2 is 8. So that means I can take 8 out of each piece. And then I want to know what's left when I take an 8 out. Well, in the first one, there was no numbers left, but I did have that x squared left. So that was left in the first guy. And note, if I did that, if I reversed that and distributed and I did 8 times x squared, I would get 8x squared, which is what I started with, okay? That's kind of the goal. It should be the same as what I started with. Next, I look at that 56x there, and I ask myself what was left. Well, the number 7 and a single x was left. I also have to look back at the original problem to see what was the sign in between them. Well, it was a subtraction sign, so that still better be negative. And then lastly, I asked myself what was left in the 48. Well, the 2 and the 3, and I multiply them together, right, because they're factors. 2 times 3 is 6. And I've now successfully factored out a greatest common factor. So I'm going to erase some of this to give myself a little bit more room. And as you can see, once I factored out that greatest common factor, what I was left with was this new trinomial that I have in the parentheses. This new trinomial is what I'm actually going to be factoring now. So I'm going to use those numbers. I'm going to use this a and this c to work through my x problem. So a times c goes on the top, 6x squared. B, my middle term, goes in the bottom, and that's negative 7x. I asked myself what things multiply to get the top and add to get the bottom. I know they're both going to have to be negative. And how about negative 6 times a negative 1? That gets me a positive 6, and a negative 6 plus a negative 1 gets me a negative 7. Feel free to use your calculator to check that. Since a happened to be 1 in this case, we don't really need to use the box. We can use our shortcut, but I'm just going to work with the box just as an example. Remember, the middle terms go there. First term goes in the first box. Last term goes in the last box. I look across the top and ask myself, what's the greatest common factor? Well, x is the largest thing that goes into both of those. Then I look this way and it's the same deal. I can confirm, does x times x equal that red x squared? Yep, it sure does. So we're good to go. Then I can ask myself, x times what gets me negative 6x? Or I can look vertically and say, hey, what's the greatest common factor between negative 6x and 6? It's pretty obvious to see that a 6 can go into both, but it might not be so obvious to see that that has to be negative. That's why I sometimes like to ask myself the question, x times what gets me negative 6x? And I'm going to do the same thing looking across here. Negative 1x and 6. Well, again, it might not be obvious to see. I know I can do a 1, and it's actually going to have to be a negative 1 because I need to be able to multiply that purple x with a negative 1 to get a negative 1x. Then I can check if those two orange things multiplied together equals what I have in the last box, we're good. Negative 1 times negative 6 is a positive 6, so indeed we have factored correctly. I'm going to take and write my answer as two binomials, two terms multiplied together. The quantity x minus 6 times the quantity x minus 1. Now to solve for the zeros, I set this guy equal to 0. Then I'm going to use the zero product property to write two equations. One that says x minus 6 equals 0, and another that says x minus 1 equals 0. In order to solve this guy, I need to add 6 to both sides of my equation. I bring down my x, those cancel, x equals 6. In order to solve this guy, I need to add 1 to both sides of my equation, bring down my x, those cancel, 0 plus 1 is 1. So my final answer is that x equals 6 or x equals 1. Let's look through one more problem here, because this one's kind of large. I'm just for practice's sake, I'm going to break this down using my factor tree. That's 2 times 7. 31 you might not know just by looking at it, but it's already prime. 1 times 31 are the only factors of 31. So that's kind of a good hint that this one really isn't going to break down any further. And 515 doesn't break down any more than 3 times 5, right? Because 5 just breaks down into 5 times 1, which we're not going to bother writing. Because as you can see, if I were to write my factors out, 3 times 5 times 1 is the same as 3 times 5. So it's not worth breaking it down any further. So as you can see, between all of those, there aren't any common factors, mostly because 31 really ruins it for us. So that means I need to move right to my x problem. Remember, a times c goes on the top. And this is where it's going to get kind of really nasty, because as you can tell, when we multiply those together, we're going to get a really large number. In this case, it's going to be 210 x squared. My b term goes on the bottom, 31x. So we're asking ourselves what things multiply to get 210 and add to get 31. And since 31 is a pretty large number, I know they're going to have to be really far, not really far, but pretty far apart. My factors will. So 1 times 210. Now can I do 2 times something to get 210 is the next question. And I sure can. If you're not sure, you check in your calculator by doing 210 divided by 2, and it would tell you it was 105. Next thing is you try 3, right? That's the next biggest number. Can I do 210 divided by 3 and get a nice number? And indeed you can. When you do 210 divided by 3, you get 70. We're getting a little closer, right? Because you can see if I subtracted these two, I would get 67, and that's a little closer to 31 than if I subtracted these two and got 103. But we're still not quite there, right? What about 210 divided by 4? I can tell you that that's not going to work out very nicely. You can divide it by 5, though, and it's 42. And you keep going, right, until you have the same factors in both columns, 6 and 35. That works out nicely. And then you can continue trying. What about 7? Yep, 7 times 30 is 210. Not too bad. What about 8? I know that 8's not going to work out. I also know that 9's not going to work out in this case. But we just keep going. What about 10? That one's probably should hopefully be somewhat obvious, right? 10 times 21. And you could keep going, except hopefully by this point you've realized, because you could keep listing a lot of factors for 210, hopefully by this point you've realized that one of these guys, I can find a combination of adding or subtracting them to get 31. Now I know that they either both have to be positive or they both have to be negative, right? Because they need to multiply to get a positive 210, right? But so if one was positive and one was negative, that would give me a negative 210, and that's not what I want. So I can kind of run through these combinations, make one positive, or make them both positive or both negative, and combine them and see what I get. So for example, here, if they were both positive, it would be 211. If they were both negative, it would be negative 211, and so on and so forth. And you just kind of run through that process, trying to figure out what things are going to combine to get a 31. And so as you keep going down and down, trying to add things together to see what your option is. Oops, accidentally erased that. We can finally see that 10 and 21 are my correct options, right? Because when I add 10 plus 21, I get 31. And when I multiply 10 and 21, I get 210. So I'm going to kind of erase those factors there because we don't need them anymore. So we can now move straight to the box. So I make my box here. Remember, first term goes in the first box, last term goes in the last box, and the middle term I split up into those two boxes. Again, the 10 and 21 could be switched. Doesn't really, their placement doesn't matter. Looking across the top, I see the greatest common factor between those is a 2 and an x. Goes into both of those. Looking vertically here, between the 14x squared and the 21x, I know that I can stick 7x into both of those. And 7x times 2x equals my red 14x squared. So we're good there so far. Now between 10x and 15, what are my common factors? Well, 5. And 5 times 2x does equal my blue 10x, so we're good. And then between 21x and 15, well, it's 3. And then if I multiply my purple 7x times my red or my orange 3, I get my blue 21x. Lastly, check. Does the orange times the orange equal the green? Well, yes, indeed. 5 times 3 does equal 15, so we're good. Now again, I'm going to write my final answer as the product of two binomials. So two terms multiplied together. 7x plus 5 times the quantity 2x plus 3. In order to solve for the zeros, I'm going to set them equal to 0 and make use of the zero product property, which says I can write two statements. One that says 7x plus 5 equals 0, and one that says 2x plus 3 equals 0, and I can solve them both. Remember, in solving, that guy on the left, it's easier to move my 5 first because he's further away from the x, so I'm going to subtract both sides by 5 and get that 7x equals negative 5. Now, that means 7 times x, so I need to divide in order to undo it, and I get that x equals negative 5 over 7. And I'm going to write it like that as a fraction. That fraction does not reduce. Same process over here. Let's move that term first to the other side. Cancels. 2x equals negative 3. And again, that's 2 times x. In order to get rid of that 2, I have to divide both sides by 2. And I get that x equals negative 3 halves, which is the same as 1.5. And I write my final answer as x equals negative 5 sevenths, or x equals negative 3 halves. And you've solved for the zeros.